good afternoon, and good evening, everyone. I am Gurveer Gill, here with Stephen Lee from Scolia Tutorial Club from Faculty of Pharmacy, University of Santo Tomas, Manila, Philippines. And today we have a lesson for our quality control subject for our first shifting. We will be discussing a couple of formulas. So this is the first portion. We will start with wavelength and frequency. We have very basic formulas which you are already familiar with, but we will Stephen Lee will discuss this for a few minutes. Mr. Lee.
So our formula for wavelength will include three elements, and that is this one, which is the frequency in per second units. This one as speed of light with a constant of 3.0 times 10 to the 8 meters per second, and wavelength, which is in meters. Sorry. And here in the quantum theory, we have another formula, but this would include the energy, Planck's constant, and the wavelength, as I said earlier. However, here our constant for our quantum theory is 6.62 times 10 to the negative 34. And since V here, as we can see as frequency's formula, will be substituted here in the quantum theory. So now we have another formula which includes the Planck's constant and speed of light, including wavelength. So here is a sample problem where wavelength is 2.5 times 10 to the negative 7 meters, and we are asked to look for energy. And how would we do this? Simply by using the formula here in quantum theory. But we can further use this formula here since we do not have any given for frequency.
We don't have a V.
Yes.
You can just expand the formula.
So by using H, Planck's constant, and speed of light, over our wavelength, which is
Here, 2.5.
2.5 times 10 to the negative 7 meters.
So basically, the answer will be in joules, and in your quizzes or exams, you will be given you will be asked for the answer in other units. For example, I think electric volts, EV, and there are a couple of other units. We'll just post it in the description. Just memorize the conversion. But this is the basic way of doing it. The first answer, you'll get it in joules. And remember, your units for wavelength should be in meters, because in the numerator, your speed of light is in meters per second. So in order to cancel meters and meters per second, your denominator, which is the wavelength, should also be in meters. And your Planck's constant is also includes that set of units.
So here, we just simply multiply and divide it, and the answer you should get should be 7.944 times 10 to the negative 19 joules. And for the units, joules second, meters per second, and meters. So simply cancel out all your units. I'm sorry. Meters here, and you get this.
Very simple. Okay. Thank you for watching.